Hello everyone, this is Gate Opener Quiz section. My name is Bhaskar Singh Chauhan and I have bring a question. Today's I have shared a question. This question is about entropy of different processes, right? And this question is very simple but little ambiguous to understand and clearly say what is going to be the correct answer. So let's start about this question. That question is entropy of an irreversible heat addition process. So first of all, I have to understand what is entropy. Another thing I have to understand what is irreversible process and what is along with this heat addition, right? So it's altogether very simple. Just start it. What is entropy? Entropy meaning like degradation of energy, or I can say it's a kind of uh, randomness in a process that actually destroy, not destroy, but somewhat degrades the quality of energy, right? So how I can calculate entropy for a irreversible processes? So I'm having very simple formula for this. Just putting this formula, ds is going to be equal to s generation plus dq upon t. So if I see for an irreversible process, only S generation is going to be existing. And the other point is that S generation is the quantity which is always positive. So it is always positive value. So I'm having S generation as a positive value. Another thing they are saying, for a system like it is going undergoing an irreversible process, along with that it is getting some heat. So if heat is given to a system, this quantity is also going to be a positive quantity. So altogether, if these two are added, this will become a positive entropy. So always increases, that could be the answer. Anyway, this question was very easy, but the question which is being asked usually about this is what about the entropy for reversible process, irreversible process, how I have to distinguish all this. So I must say the entropy for a process is always, you can say it may be positive, negative, or zero. How I can say about it? Just see this simple formula again help you out. ds is going to be s generation plus dq by t. Simply just try to understand this. It's not at all difficult. I have told that for an irreversible process, this will exist, and it will exist always with a positive value. So for a reversible process, s generation is going to be 0. At that case, ds is going to be dq upon t. Now, if heat is added to the system, that will always increase the entropy. If heat is taken from the system, that is always decreases the entropy of a system. And if there is no heat interaction for a reversible process, as I'm saying, right? So processes which are interacting with the system, means the energy is interacting with the system by reversible process, that will have entropy interaction only with dq or heat addition. So if heat is added, that is positive value. If heat is subtracted, or it is going to the surrounding, then it is negative. And if heat is not interacting with this system, then it is going to be zero entropy change. Okay, so for irreversible process, entropy generation will be there, that will be a positive value. And if I'm having, like, I am adding somewhat heat, if I'm having somewhat heat, that is going to be also positive. So these positive quantity always going to be positive, which is this case entropy with irreversible heat addition process. Another thing that I can say, if S generation is positive, that is always dq upon t, means heat is going to be going outside from the system, means coming out from the system, then it is going to be negative value, and this is going to be positive value. So this negative and positive get combined. This result is very famous, right? This result is having three possibilities. if s generation if S generation is greater than dq by t, what will be the ds value? If S generation is greater than dq by t, then this value is going to be always a positive value, because S generation is positive, dq by t is negative for heat rejection process, right? Heat rejection. Okay. Now, if S generation is positive, that is going to be always, and dq upon t is uh, having less value, then it is positive. If it is having greater value, means for example, S generation is plus 5 and dq upon t is minus 10. So this value is going to be negative. Okay. So there is second possibility. If S generation is higher than dq upon t, then it is having positive value. so entropy can be positive. And if dq upon t is I can say greater than s generation, then it is negative value. If both are equal, then it is going to be zero. What does it mean? Entropy change is zero, that you can understand it simply, that is it's a isentropic process, isentropic process. So if it is constant entropy process, then you can relate that reversible adiabatic process is also isentropic process. But this process, which in this the example that I'm having, is not an reversible adiabatic process, because in adiabatic process heat interaction is going to be zero. तो यहां से आप एक और conclusion लेके आ सकते हैं कि all reversible adiabatic processes are isentropic process. That is true, but all isentropic processes are not reversible adiabatic. That point you can conclude from here, and this is about the discussion today's quiz discussion. That is the point that you need to understand. So thanks a lot for watching this session, guys. Have a nice day.